So the SDN overlay approach you talk about, certainly that's a great way of bringing SDN in without waiting for network elements to be upgraded to support SDN protocols. I think another way of looking at it as a kind of entry point for SDN into the network is, well, where are you building out the network still? And when you're doing that, can you build out with network elements that do have inherent built-in support for OpenFlow or PCE or whatever SDN protocol you're using? So we're quite focused on looking at areas where network operators are still building out their networks and expanding capacity and putting new equipment into place, and opportunities to add value to those deployments with SDN as a sort of early way to get started. And it certainly seems to us that carrier Ethernet, whether it's used for Ethernet services to enterprises or mobile backhaul, that's an area where a lot of build out is still happening. And one of the things that SDN can do there is it can help you inexpensively extend MPLS right to the edge, and then get really good control over that MPLS, so that you can create service-aware paths through the network cost effectively, without paying for expensive MPLS edge routers right out at the edges of the network, but relatively low-cost equipment effectively can be kind of upgraded, if you like, with those capabilities. And that gets a sort of toe in the water, if you like, with SDN, and starts to build up the experience. Because one of our concerns, obviously, is that where the massive gains we see with SDN, which is like optimizing transport networks, that's going to require a greater level of maturity. It's a much more complex problem for a start off. But I think it'll take time before network operators trust their SDN controllers to start reconfiguring optical paths in the core of the transport network, because that potentially has the massive opportunities for disruption if it goes wrong. But the gains are also very large. But it will take time before SDN technology matures to the point where people are prepared to trust it in the core of the network.
It's why, as I said earlier, we need to do it step by step. But then to your point, when you say at new deployments, do you foresee any conflicts or operational challenges for an operator running two different networks from an operational point of view? If you would do it one part with a new topology and you're still running the rest with an old one.
Yeah, well, of course, sure. But I mean, I think the issue is that SDN does expose new capabilities that are not possible in today's networks.
Yeah, that we agree with.
And so you've got to get started somewhere.
Yeah.
If you reduce everything to the lowest common denominator, then you're denying the benefits that SDN brings you. And certainly, our view is, in talking to a number of network operators, extending MPLS closer to the edge. With the possibility of traffic engineered path computation right out to the edge, bringing service awareness all the way to the customer connection point, is a sufficiently kind of self-contained area. It's sufficiently easy to get your mind around, and exposes sufficient additional value that it's a great starting place.
Yeah, I would say, I mean, if you're focusing on where there's growth and you tie that back to the concept of, where are you in the network where there's a lot of service complexity and volatility. Services are changing. Yeah. Right. We're not, the landscape is changing. And you couple that with where you have the technology capability, which I would say we have the most flexibility if we're talking about virtual switching, COTS-based hardware, as opposed to trying to derive it out of an existing router. So if you use those as your starting points, you quickly find that you're in certain places, such as the peering points between carriers and route, basically where you'd have SBCs or application layer firewalls. Always a lot of change and volatility there. The bandwidths there are usually suitable for COTS at this point moving forward, so it can be software enabled. The edge points in your data centers. So not just in your data center, but as you move from your data center out to the WAN. That's another place where it's very easy to start, replacing sort of traditional routers there with software, virtual routers, virtual switches. And as you build up some of these points, CDN's another one. CDNs began as appliances like everything else, but now most of the nodes and functions can be handled in software over commercial operating systems. So we have these important touch points related to experience, at the edges of the network, be it CDNs, be it firewalls and SBCs, be it the doorways in and out of the data centers, starting to construct that in an SDN environment and controlling those virtual switching points with OpenFlow works, and then you might still be stuck with sort of the static, optical pipes and large routers in the core tying those together. But again, over time, you chip away at that. But you get a lot of efficiency just sort of bookending over the embedded network using OpenFlow switches or virtual switches.
Right.
I mean, if you look at what we're really trying to solve here, I mean, if you take a snapshot today and say the world is going to end where we are today, then we probably don't have to do much. But if you look at, we foresee 20 billion connections 2020, we're seeing data explosions, we're seeing that we're not providing connectivity anymore, we're going to provide end user experience. And if you look at all different types of machine or devices today and the way they are provisioned today, so take for instance, we're probably not going to sell iPhones or Google phones or whatever phones we have in industry, you're going to have security cameras. The way things are provisioned today in IMS, HSS, and then CSCF and other instances in network, it costs a fortune to provision these kind of network elements to start with. And then hopefully security camera will not do much because we don't get robbed quite often or fires. So there is a movement, it has to be a movement in industry to change the way of working with existing connections as the connections of the future. I don't know how you see this too, but we see this as a major point, how you provision these network elements, how you handle the service awareness of them, how you tie in OSS, BSS.
So you're talking about, for example, M2M endpoints that might need hardly any bandwidth at all, and then all of a sudden they need multiple megabits because something has happened that's of importance.
Yeah, and today you statically provision, so every time you activate a connection, you statically provision in each and every element node, and it costs quite some substantial money. Right. But the revenues that are ARPU from a user like you or me, it's probably justified the cost to do this kind of provisioning. So how would you do it with security camera? How would you do it with Coca-Cola machine?
So we're talking about maybe lots and lots of fine-grained SLAs that are very specific to different kinds of applications.
Yeah, it's the Internet of Things, and I mean the issue there is, I mean the good news is the 3GPP community IMS was built around really what is a software framework. A good starting point, right?
Yeah.
But its complexity grew and grew mainly because the focus was on providing multimedia communication services to humans.
Yeah.
And it works. It works well. I mean, our LTE network, others LTE networks, which are all IMS based, work just fine. But there's a lot of complexity in the provisioning and in the whole subscriber management because we're talking about users that have very sophisticated, endpoints, tablets and smartphones. Consuming lots of different types of services, and to apply that same structure to connecting, a camera to a database or a vending machine to, a sales repository, just doesn't make sense. You could do it, but you're talking about, orders of magnitude more endpoints now than humans, and carrying it with it that cost that might work fine in setting up a cellular network for humans, but doesn't make sense if a vendor wants to have 30,000 point of sale devices that they can go to different sporting events or stadiums with. Right? So it does take a different structure. In some sense, it's expanding some of the capability and dynamic capability that SDN and even OpenFlow could bring to the network. At the same time, it's probably dumbing down the whole sort of HSS and subscriber function because I don't want to look at every vending machine or point of sale device as a subscriber.
No.
I mean, I might have there's probably some corporation that's my subscriber, and they're deploying a whole number of these devices that they've contracted to go out across some geography. So you have to look at it very differently. And I think a combination of this movement towards COTS and doing a lot more in software on commercially available servers plays into the cost structure we need for M2M. Yep. And then applying SDN technology, recognizing, just as you've said, that a lot of these devices are trickling out almost no data, or maybe no data.
Yeah.
But you have to have the concept of that connection there, so when they need the data,
correct,
you can turn it up, and you have to manage that in a very dynamic fashion.
You go from 0 to probably to 5 megabit per second.
yeah.
And some others, they probably need 10 kilobit per second for a vending machine every now and then.
Which I think LTE and the movement towards machine to machine is a great example, a great sort of suite of use cases to apply the SDN framework into.